So now that I've got an example to work with, I'm going to show you how we actually find the first word alphabetically in this group. So here I have the names that I typed in the previous video, and you should know at this point that Alec is what comes first alphabetically. Alec and Alyssa are very close, but Alec comes first alphabetically, and our goal is to have our program find that lowest value regardless of the order in which they type the name. So I'm going to do this in kind of a weird way, and as I said before, as I kind of stated, I'm going to complete this by first assuming that Sarah is the first alphabetically. So I'm going to have a variable called first, and this is going to be me kind of tracing through to explain what we're doing, and I'm going to assume that to start, first is set to Sarah. So in order to do that, I'm going to say that first is set to the first index here, which I can type that in, because I'm going to have first equals, and I'm going to set it equal to the first word in that array. So I'm going to assume the first name entered is first alphabetically. And then from here, what I'm going to do is I'm going to have a loop. So I'm going to say for k in range. And I'm going to start k at 1, which is going to be checking the next index, which would be Laura. And it's going to go up till the end of it, which is index 7, or 8 items total. So this is going to check or run through the remaining indices that have values. So as I run this, what I'm going to do is I'm going to compare what I have set equal to first to the next value in my array. So in this case, it will be Laura, but that will be the value at name array 1, which I'm saving that value with k. So here I'm going to say if name array at k. So I'm going to say the first time through it's 1, the second time through it's 2, the third time through it's 3, the fourth time through it's 4, etc. If name array k is less than what first currently is. So what this means is it's comparing it, these are comparing ASCII codes. First word alphabetical will have the lowest ASCII code value. That's just the reality of it. So that's what we're going to do there. If name array k is less than first. So what this is saying is it's going to compare Sarah, which I assumed was first to begin with, to Laura. And if Laura's ASCII code is lower, it's going to cross off Sarah and rewrite first to be Laura. So here I'm just going to put these in. We'll put the current value in bold. So currently, first is now set to Laura. So what it did was it went in, it says it's going to compare Laura to Sarah. Laura is lower than Sarah. So what I want to happen inside of this if statement is if the new value is less than the current value for first, I'm going to take first and I'm going to set it equal to name array k. So what's going to happen each time is it's going to have a new index level. It's going to compare what's currently at that index to what I currently have first set to. I'm starting first off at Sarah, and then I'm going to start by comparing it to Laura. If Laura is less than Sarah according to the ASCII code, Laura becomes the new value for first. So if the ASCII code is lower, this becomes the new value for first. Can't see it there, hold on. Becomes the new value for first. There we go. There we go. Okay, so that's what's happening here. We're going to go through, we're going to take the name at k, which starts at 1, compare it to first. If it's less than, we'll rewrite first to be that value. So then Laura is now currently set to first. So the next time through, it's going to compare Laura to Evan. Laura is bigger than Evan, or Evan is lower than Laura. Evan comes first alphabetically. So this is going to get rewritten to be Evan. And then the next time through, what we're going to do is we're going to compare Evan to Jack. Because Evan is smaller than Jack, this if statement is false. Jack does not come before Evan, and as a result, what happens is first stays equal to Evan, and then we move on to Kyle. We compare Evan to Kyle. Evan is still less than Kyle, so no changes occur. We compare it to Michael. Michael is later in the alphabet than Evan, so Evan is still less than Michael, so no changes occur here. We move on to Alyssa. Here's the first one where the index, Alyssa, is less than Evan. So now what's going to happen is Evan gets rewritten to be Alyssa, because Alyssa's ASCII code is less than what first is currently set to, which is Evan. And then we move on and we compare Alyssa to Alec. And here we know that Alec comes first alphabetically before Alyssa, so the ASCII code will be lower. First will get set to Alec, and we're done. So essentially what's happening here is we're assuming that Sarah is the lowest to start, and then we keep comparing. We compare the two, reset it if we need to. Compare the two, reset it if we need to. Compare the two, reset it if we need to. And we basically have first that's tracking as we go through what is the highest when we compare it to all of the different values. Then at the very, very end, you'll print the first name alphabetically is, and we'll print first to the screen. So now if we run this program again, notice that I'm going to type in names in any order. So we'll do Alyssa, Sarah, Laura, Mike, Jack, Alex, Kyle, James. It goes through, and then it's able to say the first name alphabetically is Alex, even though Alex was entered in the middle. If we run it again, we can enter in names again. So here we'd get Michael, James, John, Brad. Let's do Manny, Sarah, Laura, Jacob. And it goes through, it looks at all of the names and finds that Brad is the lowest alphabetically. So it's a little confusing at first, but think about it as we're going to start by assuming the first name is the lowest, and then we're going to make really purposeful comparisons. Start with the first index beyond 0, so start with 1. Compare the two names. If the word at index 1 is lower, then you replace it and say this is my new lowest number, the new lowest value. Go back through, compare it to the next one, compare it to the next one, resetting it only if the new name is less than ASCII code-wise compared to the previous lowest name.